Okay, let's run through the first few simple, direct derivation exercises in Hardegree just to get some practice and see how you apply these direct derivation rules for these proofs. The proofs work the same way. You take the original argument, you try to reach the conclusion through these step-by-step inferences. The first few will give us some good illustrations of some of the rules and how we refer to them. Okay, so first one, okay, I'm going to write it in premise and conclusion form. Premise 1, P and Q is true. Now, your strategies for this, much like the simple derivations, you're looking for inference makers, right? And you're looking for some automatic wins, so to speak, right? Anytime you have a conjunction, you know you can use the and out rule to extract part of it. And I will illustrate this. Premise 2, P implies R and S. Okay, look for main connectors though. So for the arrow, you're going to need to use the arrow out rule before you can get to this R and S. And premise 3, sorry, it's only two premises. The conclusion is Q and S. Okay, again, talking about our strategies, right? Reverse engineering, I'm going to have to get Q. Okay, you should immediately see that you can get that using and out. I have to get S, maybe I need to get this and statement and then use and out to get S. Okay, the other way is forward-looking, looking at some automatic inferences, right? Like every time you see an and statement, you know you can use and out twice. Let's maybe start with that. Right? Without even thinking about how you use it the rest of the proof, let's use and out twice. So we get P from line 1 and out. Well, let's go ahead and just take the Q. We might need it, we might not. We do in fact need it, but I want to remind you, you can make some extra inferences. On the exam, I'll tell you how many steps you could do the proof in, but for direct derivations, you might end up taking extra steps, and that's okay. In this case, we'll use both of these. All right, now, again, look for your inference makers. You got these capital letters by themselves. Can't do anything yet with Q, but notice this P is the same as this antecedent. So we've got modus ponens, or what we now call the arrow out rule. So lines 2 and 3 give us this consequent, right, which we just pull down, identical, R and S, from lines 2 and 3, arrow out. Now your mileage may vary here. Maybe you did Q first because you saw you need it, and then you did P, right? In which case P is line 4, but that's okay. Look at the lines you used and what rule. It's still the arrow out rule. Well, now we've got R and S, and we need S, so we can pull S out. If you don't see that right away, you might take an extra step and say, well, I've got an and, may as well just go ahead and use and out. R from line 5 and out. I don't actually need that, so you could have gone straight away. You could have done this in fewer steps. You could have gone directly to S using, again, line 5 and out. Now I've got Q and S, which is my conclusion, right? So you do want to consult your conclusion, kind of reverse engineer this. Well, do I have Q and S separately? I do. Line 8. Excuse me, I'm looking at this sheet, so I just want to make sure I'm on the screen here. Line 8. I'm still doing okay. Line 8 is Q and S using lines 4 and 7. And that, by taking the two lines and combining them, you can do that. That is your and in rule. Okay, that is your and in rule. So we didn't necessarily need this step, so you could have done it in fewer steps, but there's a perfectly good derivation, direct derivation. Notice two premises. Notice how many inference steps. Again, one of them was extra, but notice how many inferences we can make just from these original premises. And minus this one, we need several steps. 1, 2, 3. We needed several steps to get to the final conclusion. As long as you reach the final conclusion, even if you take some extra steps, you're in good shape. If you didn't reach the final conclusion but took this step, you'd get credit for it because that's a legal inference, if you did it correctly. Okay, so there's the first one. Again, I have limited whiteboard space, so I'm just going to have to go ahead and erase this. You can, of course, pause your video if you want make some notes about it or just take it in. All right, but let's do the next one. The next one is going to use our or in rule, which can be hard to notice. It can hard to get used, less intuitive, hard to get used to, but very powerful. Okay, so I won't shy away from it, and it will be on, you will see it on the exam. So we have P and Q. So again, immediately you're thinking about inferences you can make. We're about detaching P and Q, and then those are some powerful inference makers. Premise 2, P or R. So I have P, I don't have P or R, right? This is hard to do, but you want to start thinking about that or in idea. It's a usefulness of the way Hardegree is setting up, because there's an obvious, like, well, if I need an or, what do? Or in. How do I do or in? Again, it's almost too simple to believe. We'll see how we'll use it in this case. P or R, in parentheses, that's the antecedent implies S. So note if I want to get to S, I'm going to need P or R, right? And then the conclusion, again, does a similar thing where we have a conjunction, right? Where we're going to get P separately and S separately, and then we're going to combine them using the and in rule. Again, in this case, I can use and out immediately, P from line 1 and out. As it turns out, I'm not going to need this Q, but again, I can't. If you're looking for things to do, one thing to do is that, again, if you haven't solved the quickest way, right, it can help just to make these illegal inferences. So I certainly can do one Q from line using and out. Sorry, Q from line 1 using and out. This step is unnecessary in that you wouldn't need it to reach the final conclusion, because once I have P, all right, what can I do with P? I can't, it's not, you don't want to deduce S here. You're not following the rules here, right? That's not the arrow out, because P is not the same as this antecedent. How do I get a line that's identical to it? Again, almost too simple to believe. I already have P, so I can make P or whatever I want, right? So you could, this would be a legal inference, P or Z. That would be legal. It wouldn't get you anywhere, but it would be a legal inference from line 3 or in. All right, but I'm going to skip, not going to show you that as an extra step. You can make this any grammatically correct, right, well-formed sentential logic statement. It could be a conjunction in parentheses or whatever you want, but all you need here is R to get this antecedent. So again, think about our strategies. Work backwards from the conclusion. I'm going to need P by itself. I'm going to need S by itself. To get S, I'm going to need P or R. And look forward to what inferences can you make. Once you do these two inferences, you can't do anything else unless, here's the nice thing about direct derivation. You can always do or in. If you're stuck, try an or in. It might be irrelevant, but just practice doing or in. Take any line and just add an or to it, or whatever you want. P or B, P or C, Q or R. These would all be legal steps. They won't get, in this case, they won't get you so further along in the proof. So you also want to be looking at strategies. Well, to get to S, I'm going to need P or R. I can get P or R by adding or to P, and I have a rule to do that, the or in rule. Since P is true, it logically follows that this statement is true. You could do the truth table test from chapter 3, right? If I gave you P and P or R, you would write P does indeed logically imply P or R. In fact, I think I gave you one to that effect to illustrate this. This is now from line 3 or in. For all these inference rules, you could do a truth table test to show that they're valid patterns, that the conclusion that logically follows from the premises. Line 3 or in. Now I've got this antecedent, and so I can proceed to use arrow out. P or R implies S, and P or R is true. Do you see how that goes? That's our modus ponens pattern. So S from lines 2 and 5, arrow out. Okay. Now the conclusion we need to reach, though, is P and S. I have those in separate lines. So again, I use the and in rule, lines 3 and 6, and in. Okay. One more, and I'm going to show you the contradiction one. Okay. 23, the next one in Hardegree, there's a couple more premises, a couple more things you'll use, so I think it's nice and instructive. And then we'll go from there. We won't use all the rules, but these are really critical rules to have in your arsenal here. Let me start with 24. So if you're looking at this, it's number 24 in this. So it's the fourth one in this exercise set. I'm skipping the third. I'll come back to the third. Okay. P implies Q, because it's a nice showing that you might have to come back to a premise and use it in a different way, and I'll show you what I mean by that. Premise 1, P implies Q. Premise 2, P or R. Premise 3, not Q. And the conclusion is R and not P. Again, realizing what we'll need, we'll probably want R and not R separately and not P separately. Notice we've got all positive P, so we're going to have to find a way to negate P. I see not Q as my inference maker. That leads me somewhere, right? And this is will get us, might get us where we need to go. Okay. So there's always lots of things you can do now with the or in rule. We don't have any conjunction, so we can't use the and out rule. But I'm immediately seeing this modus tollens pattern, which we now call arrow out, right? So I'm looking for my inference makers, and we get not P from lines 1 and 3, which we now also call arrow out. That was modus tollens, but we now call that arrow out. Notice you still have to follow that exact pattern. We haven't added in invalid arrow patterns. So our two valid arrow arguments have now become or out. Now, inference maker, right? Here's our arrow out, MTP pattern. So I get R, P or R is true, but P is false. So R is the one that must be true. That's from lines 2 and 4. Or out, which is what we now call MTP. And now I've got my R by itself. And look, oh, I also got my not P by itself, right? You can do and in any order, combine them, R and not P, right? Notice how I did that, right? You don't need these parentheses, but I took this line and this line, put an and in between as main connector, because they don't have any two-place connectors. We don't need parentheses, but that's what we did. We combined them. This is line 5. This is line 4. So lines 4 and 5 and in because we took separate statements and we joined them with an and. We introduced that and, right? The drag and drop stuff, the thing about how these statements are constructed is relevant to this and in, and out kind of idea. Okay. So again, there's your proof. That's a nice example. Now the third one, the one I skipped, let's go back to because it has some compound statements within larger statements, right? Which can be tricky to deal with. And again, if you can detach those, then you can kind of think of them in different ways. Until they're detached, you just have to think of them as a unit. Let me show you what I mean by that. We have P or Q implies R and S, right? Now, I'm immediately seeing, even though this is a complex statement, I'm seeing P or Q, or in to get P or Q, and then I can get the rest of it, okay? My mind's immediately going to that. R or T, right? Now, R or T, I have R here. Again, I'm thinking, real power of where you can use or in. R or T implies U, and the conclusion is U. Again, moving backwards. Okay, so maybe I'm going to need R or T. How am I going to get an or statement there? Oh, I have R. If I can get R by itself, that's it, part of an and statement. You have to have or in as one of the, you have to have it in mind as one of your possibilities, or you're going to miss how to complete these proofs. So I'm going to go, right, looking backwards, okay, What's the only thing can I do something with P? Only if I make it into P or Q, and I'm going to remember my OR in rule. Line 1, OR in. Now I've got this antecedent identically, so I detach this consequent just as it is, R and S. That's lines 2 and 4, arrow out. Now I can't do this straight away. I have to get this R by itself. You see, these rules work together. And if this seems cumbersome, like we're adding complications, again, if you're working with a legal contract, this might be how it is. You have this OR condition, if either of these conditions hold, then both of these conditions hold. That might be what you have in the contract, so you need to work through for yourself that since P holds, this condition holds, which means both of these holds, which means I have R by itself by line 5 and out. You could go on. You could also do another line that said S by and out, but I see that we're not going to need it, but if you do it, it's perfectly good, right? I'll just put it in brackets. I won't even number it. Just note that you can do S by line 5 and out, right? Naturally, if you do this as part of the proof, you want to number it, right? But I'm saying like you could do this, but I'm not doing it. But going straight from R to line 7, how am I going to get to U? I need R or T. Can I do that? Well, if I have R by itself, I can always add OR. Remember, you can add whatever you want. In this case, what you want is T. Okay? If you added something else, you wouldn't be able to deduce U, but it would still be a legal inference and you would get credit for that. But if you go straight to R or T, then you can make the next step. R or T from line 6 or out. Now, if you notice these multi-step things, notice all of my justifications are either 1 or 2 lines. I go to directly, where did I deduce that from, right? So R and S came ultimately from lines 2 and 4, right? R came directly from line 5. I can ignore the rest of this. I can just take each previous line and make deductions from it, okay? So you don't want to say 2, 4, and 5 here. It's always the direct inference pattern you use, and those are always 1 or 2 line rules. R or T gives me this antecedent, so from R or T, I can deduce my conclusion U using lines 3 and 7, arrow out. Okay, so those are 4 examples of what to do here with a lot of rules. I know I ran through quickly, but I've discussed some strategy and we'll discuss more in class. Let me show you the famous I put this on your implication homework. It turns out a contradiction like P and not P entails anything you like. We'll just say Q, unrelated to P's and other. It could be anything we like, and you'll see that from the proof. All right, and you can do a direct derivation with the rules you have available. Let's do and out just to get us started. Okay, this is the contradictions have a lot of deductive power because they both assert P, which is like half the, right? If you think of like each proposition of splitting the world in half between it and its negation, well, this asserts both. So there's a lot you can do with that. Of course, it's contradictory, but that's what deduction is in everything. P, not P. Now, remember the power of OR in P or Q using line 2 or in, and now, since I've also asserted not P, right, I've created an or out scenario. So, and remember, I could have added anything here. I add the conclusion I wanted. That means I can make this conclusion any statement I want, and just add it in here, and it'll have the same effect using this argument pattern. And this is showing that, therefore, that a contradiction can prove anything you like. 3 and 4 follows the arrow out pattern. I'm sorry, the or out pattern, MTP. You can prove anything contradiction, again showing us the power of the or in rule. The or in rule. Okay, we'll leave it there. There's of course more to practice, more to discuss, but that gives you some examples and a little bit a taste of some of the strategy you might use for these direct derivations.